In this short video, I will show you how to use StatCrunch to estimate a population proportion using a confidence interval. In our first example, a retirement confidence survey of 1,153 workers and retirees aged 25 and older in the U.S. conducted by the Employee Benefit Research Institute in 2020 found that 496 had less than $10,000 in savings. What is the point estimate for the population proportion of workers and retirees aged 25 and older in the U.S. who have less than $10,000 in savings? Now, when you use StatCrunch to find the confidence interval, it would also give you the point estimate, but I'm going to show you on a calculator here on the computer how to do that. So in order to find the point estimate, if they give you the number of quote-unquote successes in the sample, in this case it's 496, and if you divide that by the total number of people in the survey, in this case 1143, we find the point estimate here is about 43%. If we multiply that by 100, we want it as a percent, it would be about 43%. All right, so now we want to calculate the 95% confidence interval for the population proportion of workers and retirees aged 25 and older who have less than $10,000 in savings. So I'm going to go in StatCrunch and I'm going to click on Stat, Proportion Stats, One Sample with Summary, because I have summarized data. So here I need my number of successes, which is the number of people in the survey that said they had less than $10,000 in savings, which was 496. And then the total number of people in the survey, which is 1153. And then I'm going to go down here under Perform and select the confidence interval, and it's preset at 0.95, which is what I want. And then I'll just hit Compute. So in my output, there's my point estimate. The sample proportion is the point estimate that we found on the calculator, 0.43. Here's my lower bound here, and I'm going to type it over here because we're going to need it in just a second. So I'm going to go ahead and type it in here, 0.402. So lower bound, and the upper bound is 0.459. All right, so there's my 95% confidence interval. Put it in the wrong spot. Let's go ahead and put it down here under Part B. And the reason I did that is in Part C, we want to calculate the margin of error. And if you remember, the margin of error is half the width of the confidence interval. So if I take my calculator and I'm going to go ahead and I'm going to take the upper bound of the confidence interval that I just found, which was 0.459, and I'm going to subtract the lower bound, which was 0.402, and then I'm going to divide by 2. So for this confidence interval, the margin of error, and we usually call that ME, is equal to 0.0285, which we might round off to 0. Oh, I got it in the wrong spot. 0.0285, or round off to 0.029. All right, now let's do a similar problem, but the information is presented a little differently. This time we have a survey of 700 community college students, and instead of giving us the number of people who answered the question, they're giving us the percent. 68.7% in that survey said they had read a book for personal enjoyment during the school year, based on data from the Community College Survey of Student Engagement. So the first thing we need, because if you remember in my tool here, if I go ahead and open my tool up, and this is a nice feature of StatCrunch, in any of the tools, you can go in and edit and use the tool again. Remember, I need the successes. So I need to know how many students in that survey, not the percent, but the number of students. So I'm going to take my calculator, and I'm going to take the 700, which is the number of students that were in the survey, and I'm going to multiply by the percentage that was given to me as a decimal, which becomes 0.687, and I get 480.9, which I'm going to round off to 481. So my success is here, and I'm going to go ahead and type that over here so we don't forget. It would be 481 students. Oops. Okay, so that's what I need to use when I do my confidence interval down here. So my successes are going to be 481 out of the 700. And if you notice, be careful because they want a 90% confidence interval rather than a 95%. So I'm going to do a 90%. And let me get myself some space over here because we're going to do a margin of error in a second, and I want to have space to be able to put that in there. Okay, so the confidence interval, again, there's that point estimate. There's the 68.7 that we were given in the problem. Here's my lower bound, 0.658. I'm going to go ahead and put this over here, 0.658. is my lower bound, and my upper bound is 0.716. Okay, so there's my, and this I'm going to put next to it is the 90% confidence interval. Oh, I put 90%. All right, now I want to know the margin of error for that interval. So remember how we did that before? We took the upper bound on our calculator. So 0.716 minus the lower bound, which was 0.658, and divide by 2. So so ME here is equal to 0.029. All right, now we want to change it up a little bit, and we want to go from a 90% confidence interval, we want to switch over to a 95% confidence interval. So I'm going to go ahead and I'm going to edit again my one proportion summary window here, and I'm going to change this down here to 0.95. All right, so I've got the same output, same sample proportion because I have the same data, but I've changed the confidence level, confidence interval, confidence limits level rather. So the lower bound here, let's go ahead and put this in here, is 0.653, and my upper bound is 0.721. 0.721. Okay, and again, I'm going to type in here 95%. Now I want to find the margin of error for that interval. So again, what do I do? On my calculator, I'm going to take the upper bound minus the lower bound. So I'm going to take 0.721, and I'm going to subtract 0.653 and divide by 2. And so now my margin of error is 0.034. 0.034. So you notice what happens, because the last question says, what was the impact of increasing the level of confidence on the margin of error? Notice what happened to the margin of error. It went from, if we do it as a percent, 2.9% up to 3.4%. Likewise, the width of the interval is going to increase when you increase the confidence level.